Hello everyone, welcome to Methods Bridge. Let's get started. UML building blocks, relationships used in UML. In today's agenda, we shall see relationships used in UML like association, dependency, generalization, realization, usages. Conceptual model of UML. UML describes real-time systems. It is important to make a conceptual model and then proceed step by step. A conceptual model of UML can be mastered by UML building blocks, rules to connect the building blocks, and a common mechanism of UML. Let's look at a conceptual UML model. We have a building blocks, rules, and common mechanisms. What is meant by building blocks? We have a things like a structure, behavioral, grouping, and annotation. We also have a relationships among the things or entities like association, dependency, generalization, and realization. We represent a system using diagrams. We have a class diagrams, object diagrams, use case diagram, sequence diagram, collaboration diagrams, state chart diagrams, activity diagrams, and deployment diagrams. We have a rules for names, scope, visibility, integrity, and execution. A common mechanisms which we use in conceptual UML model are for specifications, adornments, common divisions, and extensibility. Relationships which we use in UML. We have an association, dependency, generalization, realization, and uses. Let's look at an association. Association is basically a set of links that connects the element of an UML model. It describes how many objects are taking part in the relationship. This is how we represent a notation. Let's look at a dependency. Dependency is a relationship between two things in which change in one element also affects the other. It describes a dependent element and direction of dependency, represented by the dotted arrows, dependent to independent. This is the notation for dependency. Generalization. Generalization can be defined as a relationship which connects a specialized element with a generalized element. It basically describes the inherent relationship in the world of objects. We represent a generalization notation something like this. Realization. Realization can be defined as a relationship in which two elements are connected. One element describes some responsibility which is not implemented and other element implements them. This relationship exists in case of interfaces. Usage. A situation in which one element requires another for its correct functioning. Now let's look at a dependency. Dependency is called a supplier-client relationship, where supplier provides something to client. Thus, a client is in some sense incomplete while semantically or structurally depending on supplier element. Dependency in UML indicate that a source element makes use of or depending upon a target element. Changes in behavior or structure of a target may mean change in the source. Dependency is a relationship between two things in which change in one element is also affects another. In other words, it describes a dependent element and the direction of the dependency. Represents a dotted arrow. Dependency is a relationship between the named elements, which in UML includes a lot of different elements like classes, interfaces, components, artifacts, and packages. Now let's look at generalization, is also known as easy relationship. Generalization is basically for thinking subclassing. Generalization can be defined as a relationship which connects more specific elements called subclasses with a generalized class is a superclass. Superclass is also known as a base class. And derived classes 1 and 2 are derived from base class. This is how we represent. Each instance of specific class is also an indirect instance of general class, so that we can say checking account and saving account are the accounts. Checking account is an account, saving account is an account. We represent in two ways, both are same. Because of this, generalization relationship is also informally called is a relationship. Realization. Relation can be defined a relationship in which two elements are connected. One element describes some responsibility which is not implemented by itself, but other element will implement them. Realization relationship does not have names. It is commonly found in the interfaces. The realization relationship can be employed in a class diagrams and the component diagrams. It is represented by a dashed line with a halo arrow at one end that points from a client to server, like a class to interface. Let's look at association. Association is basically a set of links that connects an element of UML model. It describes how many objects are taking part in that relationship. Association between two classes. If an instance of one class must know about the other in order to perform its work. Label endpoints of the edge with a cardinality. Use a star for arbitrary. It can be a directional. You can use arrows in that case. Let's look at an example, customer and order. Order can be associated with a customer. Customer can have multiple orders, but one order associated with one customer. Many customers can place an order. Look at an example, employees and company. Cardinality 1 to many. A company is one, but company can have multiple employees. But an employee associated with a company is one. One employee should be associated with only in one company and at a given point of time. Let's now look at a special type of association known as aggregation and composition. Let's say we have two entities called parent and child. How both are linked together and what sort of relationship they're holding with. If you look at this diagram, we could easily imagine a composition, a bit of a strong association than the aggregation. Let's look at little more in detail. In aggregation, parent and a child can exist independently. A child can exist independent of parent, other word. It's also known as a has-a relationship. Parent has a child. It is sort of a shared object. An object can exist in more than one collections. There is no ownership implied. A destroying of one object does not affect containing object. This is also known as a weak association. halo diamond symbol represented in the aggregation. On the other hand, composition is a part of relationship. A child cannot exist independent of parent. Most specific type of aggregation that implied ownership. A object cannot exist in more than one collection. The effective C, destroying a owning object does affect a containing object. It is a strong association represented by highlighted diamond. Look at this example. We have an entity called mechanic, car, and a key. The association between car and mechanic is an aggregation, has a relationship. How? Car has a mechanic. Both objects can exist independently, both parent and child. If you delete a car object, then a mechanic can work on another car. It's a weak relationship. On the other hand, key is a part of car. Key exists in only a car collection within that car object. If you delete a car, a key is useless because this key is only related to this car. So parent and a child relationship, you see, child won't exist if you delete parent. A part of relationship is a strong relationship in the association. Now look at this example. We have a entity called company, team, and employee. A team is part of a company. Team has an employee. The association between a company and a team is a composition. Child won't exist with the parent delete. Team cannot exist without company. Company owns the team. Right? Look at the other side. Team and employee. If you delete the team object, and the employee can work in another team. So the relationship, the association relationship between the team and employee is an aggregation, has a relationship. Look at one more example on aggregation and composition. Car has four wheels. The cardinality, one car has four wheels. The association between a car and wheel is an aggregation, has a relationship. Wheels can exist without car, meaning car and wheels objects can exist independently. Right? Look at a composition. College and a department, parent-child relationship, you see. One college can have more than one departments, one or more departments. If you delete college, departments won't exist. So if you delete, what that means, if you delete parent, childs won't exist. So department won't exist if delete a college. So this is a part of relationship. A strong relationship is also known as a composition association between parent and child. Let's take a look at a composition example. We have entities here: person, brain, heart, and legs. Brain, heart, and legs are the child. The association with a person is a part of relationship. It is a strong relationship. Childs won't exist if you delete parent. So it's a strong association between parent and child. Association illustrates the relationship between objects of one or more classes. Association is a group of links having common structure and common behavior. A link can be defined as an instance of an association. A degree of association denotes a number of classes involved in a connection. Degree may be unary, binary, ternary. Unary relationship connects the objects of same class. Binary relationship connects the objects of two classes. Ternary relationship connects the objects of three or more classes. Navigability can reach B starting from A. So two entities, how they are associated is what we can see more on this relationship. Now let's look at the multiplicity in aggregation, composition, or an association. We have two entities and cardinality at A is 1, at B many. One to many relationship, many to one relationship. Each A is associated with any number of B's, one to many. On the other hand, each B is associated with exactly one A. That is how the representation means to us. Look at multiplicities. For instance, when you see star, this means we have one or more unlimited number of associations. 0 to 1 means either 0 or 1. If you see 1, it exactly one cardinality. N means like number, n cardinality, like a 4 wheels, 4 is a cardinality. 0 to star, either none or many. That is a relationship. If you put a number like n and m, n through m means a specific range can be represented with an and m relationship. How do we know which UML relationship is to choose while you're developing your models? Right? Use association when specific objects have a multiple relationships, persistent. Use dependency when working with static objects or if there is only one instance. Aggregation is part of, is made of, contains. If any of them make sense while you're working on models, you can easily identify that is an aggregation relationship. Do not confuse part of relationship with the is a relationship. You can practice, you will be able to identify easily which relationship to choose.
Thanks for watching. Please like, share, subscribe, click on the bell icon and please leave the comment. Happy learning. Thank you. Stay tuned to the upcoming sessions.